Students. Hi, algebra students. We're going to be working on section 3-4 today, dealing with equations in standard form and finding x-intercepts and y-intercepts. So I'm going to go ahead and share my screen so you can see today's presentation. And we start with an exploration that's actually on page 74 in your journal. So go ahead and grab your journal and try this problem. It's exploration 1 on page 74. So go ahead and pause the video and give it a try. All right, welcome back. Let's check to see how you did. It says you sold $16 worth of tickets to a fundraiser. You lost track of how many of each type of ticket you sold. Adult tickets were $4 each and student tickets are $2 each. Let X represent adult tickets and Y represent student tickets. Use a verbal model to write an equation. So I'm going to fill this in here. We know that the adult tickets are $4 each. So we have, oops, let's go back. I need to grab a pen here. So we have 4 times each number of adult tickets we sold, and 2 times each of the children's tickets we sold, and we sold a total of $16 worth of tickets. And so we're going to try to figure out on part B what the possible combinations are here. So let's say we sold here, well, what if we sold 4 adult tickets? Let's think of all the combinations we could come up with to get 16. So if we sold 4 adult tickets at $4 each, that would mean we sold 0 children's tickets. All right, what if we sold 3 adult tickets? Well, let's see, 3 adult tickets would be 4 times 3 is 12. So we still have $4 left for the children's tickets. So that would mean 2 children's tickets. All right, what if we sold 2 adult tickets? Well, that would be 4 times 2 is 8, which means for children's tickets to come up with 16, we'd need $2 times 4 tickets, so 4 children's tickets. 4 times 2 is 8, and 2 times 4 is 8 for a total of 16. Let's say we only sold 1 adult ticket. Well, we have $16 altogether. If we sell 1 adult ticket at $4, that leaves us $12 left for children's tickets, and they're $2 each, so that would leave us with 6 of that. Or it could be that we didn't sell any adult tickets. And if we sold $16 worth of tickets to children and the children's tickets are $2 each, then that would mean we sold a total of 8 children's tickets. All right, so this is one of those cases where we have discrete data, right? Discrete domain. We can't have like partial tickets. Our only possibilities to come up with $16 are these numbers, either 4 adult tickets, 3, 2, 1, or 0. There can't be halves or partial tickets in there. All right, today we're going to be looking at equations in standard form. This vocabulary is on page 76 in your journal, so please copy down what standard form is and what x and y intercepts are. All right, hopefully you got that copied down. The other thing that's on that page are a couple of core concepts about horizontal and vertical lines. So I'm just gonna, oh, I do that every time. I'm gonna draw in my axes here. All right, x and y. I'm going to draw another one here, x and y. And on that page 76, it talks about horizontal and vertical lines and what those look like. So if I have just some number in here, and let's just make this line I'll make it at +3. This would be the line y equals 3. So if you have a horizontal line, it's always going to be in the form y equals something. If I have a vertical line, let's make it go through 4 here. if I have a vertical line, and mine doesn't look very vertical because I'm kind of sideways here, that is going to start with just x equals, and in this case, it would be x equals 4. So anytime you see just y equals a number, it's a horizontal line. If you see x just equals a number, that's a vertical line. All right, so we're going to jump to page 77 then. We're going to try some extra practice problems. So here we have an example of just y equals and just x equals. So again, if you see just y equals -3, that's a horizontal line. So you're going to go down 3 on the y-axis. So there's -3. And I draw a horizontal line. Whoa. I attempt to draw a horizontal line that passes through that point. I don't know if the eraser works. Let's see. I don't think I have an eraser. That's too bad. All right. So let's stick with pen here. All right, and this time x equals 2. So if it's just x equals, it's a vertical line. I go 2 on the x-axis and draw a vertical line. So it's a little better with vertical than horizontal. All right, extra practice. Let's keep going. It says to find an x-intercept, set y equal to 0 and solve for x. To find a y-intercept, set x equal to 0 and solve for y. And this is in your journal on page 77. Oop. Your pen. So if you need to remember that, it's on page 77. All right, so on these problems, on problems 3 and 4, it says, find the x-intercept and y-intercept of each function. So first of all, I want to find the x-intercept. And I'm going to abbreviate that as int. So it says to find the x-intercept, I put 0 in for y and solve for x. So I'd have 3x plus 4 times 0 equals 12. Well, 4 times 0 is just 0. So I'm left with 3x equals 12. I divide both sides by 3, and I get x equals 4. So my x-intercept is 4, which means it goes through the point 4, 0. Right? My y value was 0. My x value is 4. All right, I'm going to switch color here. So this time I want to find the y-intercept. So notice when it's in standard form, it's really easy to find these intercepts. So to find the y-intercept, I'm putting in 0 for x this time and solving for y. So this time, 3 times 0 is 0. I'm left with 4y equals 12. I divide both sides by 4. And I get y equals 3. So my y-intercept is the point 0, 3. All right, we're going to do the same thing on number 5. So I'll switch back so I'm consistent with my color here. I'll go back to the blue for x-intercept. So again, for x-intercept, you're putting in 0 for y and solving for x. So 5x minus 2 times 0 equals 30. 2 times 0 is 0. That gives me 5x equals 30. Divide both sides by 5. And I get x equals 6. And again, to write that as an ordered pair, it's the point 6, 0, because our y value was 0. To find the y-intercept, I'm going to put 0 in for x and solve for y. So be careful you don't lose the signs there. We have some negatives in this problem. Oh, well, speaking of which, this should have been a negative, and this should have been a negative, which would have given us -6, 0. All right, so let's keep going. This is 5 times 0 is 0. So I have -2y equals -30. I divide both sides by -2. And I get y equals, a negative divided by negative is a positive 15. So my y-intercept is the point 0, comma, 15. All right. Let's look at the next slide. Grab a pen. So this time it says use intercepts to graph the linear equation. So you're going to encounter one like this. It's nice. We have been graphing with y equals mx plus b and finding our y-intercept and our slope. But when it's in standard form, it's really handy to use the intercepts. So remember, to find the y-intercept, I put 0 in for x and solve for y. To find the x-intercept, I put 0 in for y and solve for x. So let's first do our x-intercept. And again, we're going to put 0 in for y and solve for x. So if I put a 0 in here, this term goes away, and I'm left with negative 8x equals 24. Divide by negative 8. And I get that my x-intercept then is negative 3. And again, x-intercept, you have the point negative 3, comma, and it was 0 for y. So I know my x-intercept is negative 3, 0, and I'm going to graph that. All right, my y-intercept, to find my y-intercept, I put 0 in for x this time, so this term disappears because negative 8 times 0 will be 0, which leaves me with 12y equals 24. I divide both sides by 12. And I get that y is equal to 2. So my y-intercept is the point 0, comma 2. So to go to 0, 2, it's 2 on the y-axis, right? We are graphing a linear function, so I want to draw a line that passes through both those points. See how nicely I can do it here. All right, let's make this a chubbier dot. And remember, lines go on forever, so you can put some arrows at the end. All right, let's do that same idea for the next problem. So we're going to start with our x-intercept again. Remember, when you're finding an x-intercept, you're putting 0 in for y and solving for x. All right, so if I put 0 in here, this would just be 2x plus 0 equals 4, or just 2x equals 4. I divide both sides by 2, and I get x equals 2. All right, so my x-intercept is 2, 0. Which is going to be right here. All right, switch colors again here. I'll go back to blue to find my y-intercept. I'm putting 0 in for x and solving for y. So 2 times 0 would be 0, and I just end up with y equals 4. So my y-intercept is the point 0, 4. So I go up to 4 on the y-axis and make a point. I'm going to change colors again to draw my line. And I draw a line that has to pass through these 2 points. So it looks like, oh yeah, beautiful. Hopefully yours looks a little straighter than mine. And that's our line. All right, let's look at the next slide. All right, this time it says the school band is selling sweatshirts and baseball caps to raise $9,000 to attend a band competition. Sweatshirts cost $25 each and baseball caps cost $10 each. The equation 25x plus 10y equals 9,000 models this situation. So find and interpret the intercept. So let me grab a pen. All right, so it's asking us to find the intercept. So the x-intercept, remember we're going to put 0 in for y and solve for x. So that would give us 25x is equal to 9,000 because 10 times 0 is 0. All right, then I need to do that. All right, grab my handy calculator, and I'm doing 9,000 divided by 25, and I get x equals 360. All right, so it's asking us to interpret this. So if you're trying to raise $9,000, you would need to sell 360. We got to look at what X represented again. X represents the sweatshirts. So you would need to sell 360 sweatshirts and no caps. All right, the other option was baseball caps, but we're selling 0 of those to raise the $9,000. All right, so if you didn't sell any baseball caps, you'd have to sell 360 sweatshirts. All right, so that's the x-intercept and interpretation. All right, let's look at the y this time. So y-intercept. This time I'm putting 0 into x and solving for y. So I have 10y equals 9,000. And that is a 9, by the way. It kind of looks like a 4. All right, so this time we get y equals 900. All right, so let's interpret what that means. So remember, y represents the baseball cap. So this time, if you didn't, oh, I don't know why my pen always goes so crazy at this point in the slideshow. If you didn't sell any sweatshirts I'm just going to abbreviate, you need to sell, actually move me out of the way here. You need to sell, ooh, getting some crazy writing. You need to sell 900 caps. All right, because remember, you're trying to raise $9,000. And if you didn't sell any sweatshirt, that you'd have to sell a lot of baseball caps. All right, the next part says 258 sweatshirts are sold. How many baseball caps are sold? All right, so we know how many are sold. We know we're trying to model this. So we're doing 258 times sweatshirts. Remember, sweatshirts is X, so 258 times 25 plus, we don't know how many baseball caps we sold, but we know that the goal of 9,000 was met. At least that's what we're assuming here on this. All right, so we're going to do 258 times 25. And that gives us 6,450 plus 10y. Remember, we're trying to figure out caps, equals 9,000. All right, so I'm going to subtract 6,450 from both sides. All right, so 9,000 minus 6,450 leaves us with 2,550. All right, then we're going to divide by 10. It kind of, when the pen gets so weird, it looks like some kind of Greek weird writing. All right, so we get y is equal to, and that's a y, 255. So when it asks you if 258 sweatshirts are sold, how many baseball caps are sold? It is 255 caps. All right, the next part says find 2 more possible solutions in the context of the problem. So you can kind of pick whatever you want. Like, let's say you sell 100 sweatshirts. All right, so let's let X equal 100. All right, then we'd have 25 times 100 plus, we don't know how many caps, right? That's what we're solving for, equals 9,000. So 25 times 100 is 2,500. And my pen is getting so nutty, I might have to give up here. All right, so subtract 2,500 from both sides. So that would give us, let's see where I can write this. I'll go way over here. Ooh. All right, so that gives us 10y is equal to, and we have 9,000 minus 2,500 equals 6,500. And divide by 10. And so in this case, one of our solutions is if we sell, and hopefully we can get this to work here. That's a 6. If we sell 100 sweatshirts, we would have to sell 650 caps to make $9,000. All right, you're supposed to come up with another solution. My pen is being cuckoo, so I'll leave that one up to you to try to figure out. All right, your assignment today is on page 133. The pages for this are linked in the agenda calendar in Schoology, so you can find the pages. You're doing problems 3 to 16, 23, and 29 to 34. I would like you to use graph paper. So if you don't have any at home, you can maybe print some off the internet. And if you're in class, I will provide you with some graph paper. Be sure to check Schoology, see if you're missing any assignments. We do have our chapter test coming up on Friday, the 20th. So make sure all of your Unit 3 work is turned in before then. All right, good luck. Email me if you have any questions.